Your phone's autocomplete just predicted the next word you were about to type. A camera at an airport flagged a face in a crowd. A doctor got an early cancer warning from a scan before any human radiologist looked at it. None of those systems were explicitly programmed with rules. They all learned. And in the next 7 minutes, you're going to understand exactly how that works. This video is for you if you've heard the term machine learning 100 times and still feel like you're missing the actual mechanism, the how. By the end, you'll be able to explain supervised learning, understand what training data really does, know where neural networks fit in, and you'll have a concrete mental model you can build on. No math degree required. Let's start with the core idea. Traditional software is a set of explicit instructions. You tell the computer, if the email contains the word prize and comes from an unknown sender, mark it as spam. You write the rule. The computer follows it. Machine learning flips that. Instead of you writing the rules, you feed the system thousands of examples, spam emails and non-spam emails, and the system figures out the rules itself. It finds patterns you might never have thought to write down. That's the whole paradigm shift, right there. Now let's get specific. There are 3 main flavors of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Most of what powers everyday products is supervised learning, so let's start there. In supervised learning, you give the model labeled examples. Labeled means every data point comes with the correct answer attached. A picture of a cat, labeled cat. An email marked spam. A house with its sale price. The model learns the relationship between the input, the picture, the email, the house features, and the output, the label or the number. It adjusts itself over thousands of iterations until its predictions get consistently close to the right answers. Here's a real example. Scikit-learn is a free Python library that lets you train a supervised model in about 10 lines of code. You load a dataset, say, the classic iris flower dataset, which has measurements of 150 flowers across 3 species. You split it, 80% for training, 20% for testing. You call random forest classifier, fit it to the training data, and then ask it to predict the species on the test set. It hits around 96% accuracy out of the box. That's a real, runnable example you can try at scikit-learn.org right now. So how does the model actually learn? This is where the word parameters comes in. Think of parameters as the knobs inside the model. At the start, they're set randomly. The model makes a prediction. It compares that prediction to the correct answer and calculates the error. This is called the loss. Then it nudges every knob slightly in the direction that reduces the error. Repeat this millions of times and the knobs converge on values that make good predictions. This process is called gradient descent, and it's the engine under the hood of almost every ML model alive. Now, where do neural networks fit in? A neural network is just a specific architecture for building a model, one that's loosely inspired by the brain. Instead of one big set of knobs, you have layers. An input layer takes in raw data. Hidden layers transform it, detecting edges in images, patterns in words, correlations in numbers. The output layer gives you the prediction. Deep learning just means a neural network with many hidden layers, sometimes hundreds of them. GPT-4 has around 1.8 trillion parameters. That's 1.8 trillion knobs being tuned during training. The more layers, the more abstract the patterns a model can detect. A shallow network might learn that a straight horizontal line is an edge. A deeper one learns that edges make shapes, shapes make ears, ears are part of a face. Each layer builds on the last. That's why deep learning transformed image recognition, speech-to-text, and language models. But none of this works without data, good, representative, large-scale data. In 2012, a neural network called AlexNet trained on 1.2 million labeled images from a dataset called ImageNet and cut the image recognition error rate almost in half compared to previous methods. That single result triggered the modern deep learning era. The algorithm wasn't magic. The scale of the training data was. Here's what you should walk away with. 1. Machine learning finds patterns in data instead of following handwritten rules, the data teaches the model. 2. Supervised learning, the most common type, needs labeled examples input paired with the correct answer. 3. Training is just the model adjusting its parameters repeatedly to reduce prediction error using gradient descent. 4. Neural networks are layered architectures that let models learn increasingly abstract features, and depth is what makes them powerful. 5. Data quality and quantity matter enormously. A mediocre algorithm on excellent data usually beats a brilliant algorithm on bad data. Here's my question for the comments. What do you actually want to build with machine learning? An image classifier? A text generator? Something for your own job? Drop it below, I'll try to point you toward exactly the right starting resource. If this clicked for you, subscribe, because next we're going hands-on, building your first real neural network in PyTorch from scratch, no fluff, just code.